Hi, in this video we are going to implement messaging queues in our backend in order to scale the system. Let me show you what's in my mind. Let's say you have a backend microservice here and you have multiple users. Let me draw the users right here. I'll just zoom in a bit. Let's say you have 10 users and your system has an endpoint named queue. Maybe your SaaS is providing file processing or maybe video processing systems. Let's say there are 10 users and they are making 10 calls per minute to this endpoint. And this endpoint is only for receiving the request, and this might be delegating the task to another microservice. Let's say there is another microservice. This one is for file processing. Let me name this file or maybe video processing microservice. This is video processing microservice and this is user management microservice. User management microservice. And this microservice, the video management, might have two portions, like in which the video is actually being processed, video processing, and another portion in which after the video is processed, upload to cloud bucket bucket, and then maybe email to users, just to notify them that their video has been processed and this is the URL, they can access the video right now. So once any user reaches out to this queue endpoint, it will delegate the task to the video processing system. The connection between these two microservices can be done in many ways. Maybe this video processing endpoint, maybe this video processing microservice has an endpoint like API v1 requests, or there could be another way. In this way where it has an endpoint, this queue would be making multiple calls to this endpoint, multiple calls. Like if there are 10 users making 10 calls per minute, there would be at least 100 calls made to this endpoint, and this video processing microservice must be doing something like OpenCV or maybe FFmpeg operations, OpenCV/FFmpeg operations, which are really intensive, CPU intensive tasks. So these operations takes a lot of time, so we can't just simply do API calls to these endpoints. Let's remove this, and let's also remove this endpoint, but instead of endpoints we can simply use a messaging queue. So instead of just directly going to this microservice from the first one, we can simply implement a messaging queue. Let's do messaging queue, which works on FIFO principle. There are of course some exceptions, we will talk about that, which are mainly priority based exceptions. Once a user reaches out to this queue, maybe their job is J1. Just to denote the job, we have named it J1. Once the endpoint has been approached with a job, it just simply puts the job into the messaging queue and it becomes the first element in the queue. So what the job looks like, it may look like this. Maybe it has a property called process video. Then it might have user ID key. Maybe that could be 1044 or whatever random number. Then it might have something like video file, something .mp4, then maybe hash, whatever key or token, random, something similar. So this would be sent to this queue endpoint and this whole object would be put to the queue. So let's say 100 users request in a moment. So similar to this J1, more jobs would be sent to this queue like J2, J3, J4, J5, J6, and so on and on. Once the messaging queue starts filling up, this video processing microservice will spawn workers from this queue. So this will spawn workers. These workers will be listening to this queue. Once a job has reached the queue, it it will simply take the job out from the queue. Like this J1, it will take the job from the queue and it will start processing this job. So let's say this job, this whole thing will be received in this via the queue. Now the video processing microservice can access the video file and do whatever operations needed. Then after the operation is done, it can simply do the post-processing task like uploading to the cloud bucket, then emailing the key and object URL to the users. So let's say the J1 is done. So once the J1 is done, the job 1 is done, it will simply run a function like job.done or job.remove. This job would be removed from the queue. Then the J2 would be the first element in the queue. Then this J2 will be processed in the video processing server. Once the J2 is done, then consecutively J3, J4, J5 and J6. Now here is a twist. Let's say here is a user who has purchased premium, like pro user. Let's say this user is a pro user, the left one, the person in the left. Let me just select this. Yeah, let's say this person is pro user and there are free users who has multiple tasks ongoing, but this pro user needs attention before anyone else. So what this user has done is that he has also made a call to the queue, but his object looks like this instead of something like this where he has a video file and all. He has another key like user pro. So this would be sent to this queue endpoint with the key user is equal to pro, and now this job would be sent to the queue as well, like let me tell you J7. But here's a twist. The J7 is not just a simple object, but it also has this user pro property. Just because it's a task given by a pro user, it will have a priority number. So the priority numbers can be from 1 to 10. So the lesser the number, higher the priority. J7 would be having this key as well. Priority would be 1. So this has to be processed before anything else. Once the J7 has reached with priority 1, the queue would leave all of these tasks and simply send this task to the processing unit. Then this task will be processed. Then after this J7 has completed, the J3, J4, J5, J6 will be processed. For the messaging queues, we would be using Bullmq, which is powered by Redis. So we need to spawn a Redis process, or you can also use providers like Upstash or Ivan or anything else. We would simply create a Docker compose and run Redis locally on our Docker. So I have opened a VS Code. Let's create a YAML file, Docker compose. So I would name this Redis spawn.yaml. You can just simply name this Docker compose. So let's define the version of Docker compose we would be using. For me, this is 3.3. Then define the services. The first service that we would be spawning is Redis. Name the service Redis. Then what image we would be using? We would be using official Redis image. That too version is 6.2.0. You can look up the versions in the Docker Hub. This is the Redis official image. There are some recent tags and all. So the container name I would like to give this is Redis itself. Then always restart this, always. Then the ports I want to expose is that Redis has its own port 6379. Expose the 6379 from Redis to my device's 6379 itself. And then volumes, let's define some volumes. Redis volume data, and it will be having data. And let's define this volume at bottom. Volumes, Redis volume data. And we need another volume for Redis Insight. Redis Insight volume data. Yeah, we need that as well. So now Redis is complete. Let's create another service, which would be Redis Insight. We would use Redis Insight image, Redis labs. You can just simply look this up. Redis Insight. We would use the image from Redis labs, this Redis Insight, and the latest version of it. Then container name would be similar format, Redis Insight. Then always restart, always, and then ports would be, previously Redis Insight used to use 8001, but they have now updated it to 5540, so we have to map the 5540 as well. And the volumes we would be using is this, yeah, Redis Insight volume data, and this would be mapped to DB. Yeah, we will now have to run this Docker Compose. So if you are using the name Docker Compose, then you would simply had to do Docker Compose up. But now as we are using some different name, so we would have to give a name with a flag, Redis spawn up. Let's see. Create file. The system did not file. Okay. /.yaml. This Docker daemon is not running. Okay, you have to run the Docker daemon. I have started the Docker desktop. You can simply download it from the internet. Docker desktop takes some time to run. Once it has started, the Docker daemon would start along with it, starting the Docker engine. As you can see, yeah, the Docker engine has started. Now let's do the same command. It will first pull the images if you have never pulled Redis images before. So it takes quite a bit of a time, so hold on to your seats and get a cup of coffee. So once you reach this state, you can simply go to another terminal and do docker ps. You'll be able to see that Redis Insight and Redis containers has been spawned up. So now you can just simply go to localhost 5540 for Redis Insight, and you will be able to see the Redis Insight has been spawned up. So you have to just click on this checkboxes, and you can simply do add connection details manually. So once you click on this will by default give you the localhost IP and the port of Redis 6379. But you can't just simply add Redis database like this. If you are using Redis Insight after downloaded version, you will be able to do that. But as we have spawned up different containers, both are isolated environments, so you need to get the Redis's IP address. So for that, I will go to another terminal, and there is a command called docker inspect. I actually forgot the syntax, so I will just simply look up in docker inspect, find IP of a container. So let's get help from Stack Overflow, and let's copy this one. I remember this, but actually I forgot the syntax. Paste, and then you have to give the container name at the end. So I would simply do Redis, and this is the IP of our container. Let's go here inside the host. I would replace the IP of the Redis container and in the database alias as well. And now click on add Redis database. You can see Redis database has been added. Now let's confirm that if our Redis is even working or not. Come to the workbench, execute this command, set job to processing. This is set is command, this is a key, and this is the value. Then execute this with maybe control enter. This will return okay once it has successfully saved in this in memory. Now in order to grab this, you can just simply do get, then the key, which is job, then control enter. You can see this is sending us processing string. So the Redis is perfectly working. Now we also have to do one thing, that we have to switch to the tree view. You can see the string job has been saved with the key processing. So let's go back to our VS Code And now let's just simply create the microservices. So you can simply assume that both the microservices would have been in different servers, different places, but as we are coding it here, we would simply keep both the microservices in simple JavaScript files. Two of the JavaScript file would be created here. Let's name it user backend or simply user.js. Let's assume this is a microservice 1 as shown here. This is the first microservice, user management 1, user.js, and there will be another microservice which is file processing 1, and we will simply name this file.js. Now let's start with the user.js and use Redis based Bullmq here. For that, let's first do npm init -y, and we need to install some things like Express for creating a server, then Bullmq, and if we need UUID, just for backup we are installing UUID. Let's press enter. Installing these packages might take a bit of time. In the meantime, let's just start with this. Import express from express, then import q from Bullmq. By the way, as we are using ES6 modules, let us explicitly mention this here. Type is module, not CommonJS but module, and let's do const app is equal to express, and then do app.use express.json. This is just to add the middleware so that we can pass the JSON requests. And let's create an endpoint, app.maybe post, and the endpoint name was queue, and it would have access to request and response. And let's make this asynchronous function, async, and inside this we would do simply console log request.body and res.send fine. Let's use Postman, and while the Postman starts up, let's simply do app.listen on maybe port 8080, and the callback should be console.log port server running on port 8080. Okay, let's start this node user.js or maybe node user, and then in Postman we do this post request localhost 8080/q, and body should be raw and JSON. Let's add something random, user ID. Let's add this as 10. Send. This response is fine as we did. Response is fine, and console log is user 10. Now we can confirm that our the most basic Express server is working. Now let's create a queue. Const queue would be new instance of this queue. In this queue, first argument would be our queue name. We would name the queue image processing queue, and the second would be our connection details. For our case, we can just simply pass the string Redis, then localhost 6379, and now this queue can be used inside the endpoint. Now let's use this queue. Instead of the response, let's do try catch block, and we will simply do await queue.add. This queue.add will add a job. Let's name the job processing, as we are implementing video processing, so this should be self-explanatory. And the data, we will wrap this inside an object. First, the task name should be request.body task name. Then we will send the user ID, request.body.user ID. If you want, you can also sanitize the request body and make some validations and all. If the user ID is proper in the proper format that you want, then move forward with the ID. So we want to generate a dynamic ID. So for that we will use UUID. So we would do import v4 from UUID. So I haven't used UUID. V4 is available. So let's name this as UUID. Now let's use this UUID. You can just simply use this UUID function, and this would provide you an alphanumeric separated by hyphens and all, one random string. But we want a simple file name or something. So for that we would use template literals, then $UUID function, then after that MP4. So random MP4 file name would be generated. So instead of ID, we can just simply do a file name. Yeah, this is better. So in actual application, you would simply pass an absolute URL here. So once the job is added to the queue, we would simply do res status 200 and send that task has been added to the queue successfully. And if any error occurs in case, so we would simply log the error, console log error dot message, and we would send the user that an error has occurred, so error 500, and send error queuing the job. Yeah, I think this would be enough for now. And in the worker, the file processing unit, we would be adding workers itself. So let's spawn workers here. So worker, import worker from Bullmq. Now let's spawn a worker. Const worker is equal to new worker. Worker. So this takes 3 arguments. First one is the queue name, as we previously provided. This is image processing queue. Second one is the actual function that it would run once anything has added up or any job has been added up to the queue. This is the function like this. Whatever function we want to add, we will replace it here. And the third argument is the connection string. For that, this time we will just simply add this connection, and inside this we can simply send the string, but we would do something better. We would export a variable, export const redis connection. Host would be our localhost, then port is 6379, and we would pass this redis connection here. As simple as that. Let's replace this function. Let's create a function called image processing queue, or maybe const process task. Let's use this function here, right here. Now it would have a parameter called job, and this would be async function. So let's do async, and this would have a job. Each job will be, let me show you in a moment. We are already running this node user. Let's create another server and do node user. Server running on port 8080, and let's hit this endpoint queue with this kind of payload. We would simply modify this payload like task. Let's wrap this, and this should be something. We do not need to send the file name. We only need to send the user ID and all. So the task name should be video processing, and user ID, let's give a random number. Yeah, and let's click on send. Task has been added to the queue successfully. Now let me check the Redis Insight. Let's refresh it, and you can see inside the bull you have this queue, image processing queue. Once you expand it, you have all these things, and now inside this queue you have this job. This data property is having user ID and file name. Why not the task? I guess we have not changed the key. Yeah, this key is named task, but in backend we are only receiving request body task name. So let's give it task name. Yeah, video processing part 2, and change the number, and again send this, And again, when we refresh this, you can see the #2 is here, and data you have the task name, video processing part 2, user ID, and file name, some random string .mp4. Now let's come to VS Code, and we need to work on this processing task. Let's say you are running ffmpeg functions for video processing. ffmpeg functions implemented here, and this function might take a bit of a time. Let's say for our example, minimum could be around 3 seconds. Await new promise, resolve. After 3 seconds, resolve this, resolve. 3 seconds. This is a simple sleep timer, and this indicates the video processing time. So after this, we would simply console.log video processing has been done, and we would also have to give the ID for which video processing actually has been done. So we would simply do job.data.user_id. This is job.data. This is whole job. This whole thing is job, and this is the data field. And inside this, we would simply give user ID for which user the processing has been done. User ID. Yeah. For user. Yeah. Let's start the worker as well. Node file. You can see after 3 seconds, it has said that video processing has been done for user this, and then video processing has been done for user that. Yeah, we also need to make another console log once the process task has started. So we will simply do console.log processing task number, job.data.user_id, and file name is job.data.id. Yeah, I believe this was ID. No, this was file name. File name. Let's see it in action. Let me split the screen again and Postman where it is. Yeah, video processing part 3 and another random ID. As soon as I click on this send, it will simply send this data to Redis, and as this worker is listening to the Redis stream, as soon as this is added to the Redis, this will start implementing the processing. So I'll click on send. You can see video processing has been done for user this. So I'll simply close this and restart node file, and again video processing part 4, add some random number, click on send, processing task number this, file name is this. After 3 seconds, it console logs video processing has been done for user this. Let's say there are 100 users sending this kind of payload to this endpoint under a minute. So there is also another pro user, as we mentioned here. The pro user's request has to be processed with priority. So we also get this inside the queue. In the queue, when we add this job, we also get this option called priority. In that, we can add something called priority, and let's say the priority is 1. As I have already mentioned, the priority can be from 1 to 10. Lower the number, higher the priority. If a job is having priority number 1, so it would be executed before anything else. Then if a job is having priority number 3, compared to 1, it will be done later. So let me simply make this dynamic. Instead of just simply hard coding it 1, we would receive it from the payload itself, request.body priority, and we would have to send the priority from Postman. Let's say priority, let's say we are sending it to. I have closed this file processing unit. Let's start this server, node user. Now this will take effect. Now let's come to the file server and let's add priority number 3 first. Priority number maybe 7, then 1, then suddenly 10, then 5. Yeah, once we have added 4, let's now do node file. You will be able to see it will be processing everything from task 1, then it would be the highest number after this, task 3, then would be task 5, then it would be task 7, then task 10. It is now processing all the tasks based on its priority. Instead of manually giving this number, let me use a prerequisite script. So I will simply set some variables like pm.environment. You get this Postman pm.environment, then set user ID, which would be math.random. We want a random number starting from 0 to 1000, and we would do simply 1001, and we would convert this in math.floor. Yeah, and similarly, let's create another variable called priority, and this would be starting from 0 to 10. Now we have two variables. Let's replace this user ID with this and priority with the priority. Yeah, now let's send a couple of requests. Send, multiple sends has been done. It is saying processing task number this, task number that. Again, let's close the server for file processing. Now let's add a few jobs to the queue. We would click on send, and you can also inspect this inside this console. We'll clear this console and send. Again, send multiple times, click on send. You can see all these jobs are added to the queue. I have added a few, and now clear this and again run this node file processing. You will be able to see it will process each task after 3 seconds of interval. Once a task has been completed, it will take up the next task or the next job. So this was simply it, a simple demonstration and implementation of messaging queues. I have implemented the same architecture in my backend emailing service. Using queues, I have delegated the emailing service to another microservice in order to improve the performance of the main microservice. So this was all for this video. If you want to access the source code, the GitHub link would be given in the description. And if you have some questions, you can drop them in the comments below. See ya.